Every 23 hours, 56 minutes, and 4 seconds, our planet completes a single rotation. While we perceive it as the simple passage of time, this motion serves as the engine powering the global circulation of our oceans and the structural behavior of our atmosphere. To understand how that engine functions, we must imagine what happens if it fails. In this thought experiment, we ignore the external force required to stop the world and focus entirely on the physical consequences of the halt itself. This animated diagram reveals the core physical paradox of a sudden stop. While the solid crust is fixed in place, the atmosphere and oceans continue spinning eastward. The ground stops, but everything resting upon it retains its existing angular momentum. At the equator, the surface currently moves eastward at roughly 1,670 kilometers per hour. Stopping the ground creates a violent discrepancy between the stationary rock and the fluids still traveling at supersonic speeds above it. Analyzing this impossible transition reveals the hidden physical momentum that defines our environment. In the seconds following the halt, a global mismatch takes hold. The ground is fixed in place, but inertia carries everything else forward, throwing air, water, and unanchored objects eastward. Geography dictates the destruction scale. This diagram shows eastward velocity vectors across latitudes. The longest arrows at the equator represent 1,670 kilometers per hour. Toward the poles, that speed decreases. At the geographic axes, surface motion approaches zero, creating a global gradient of inertial impact. This generated video illustrates the oceanic response. Because the oceans cannot instantly match the halt of the seafloor, massive volumes of water continue their eastward path, surging deep into the interior of newly stationary continents. This immense relative motion effectively erases every established oceanic circulation pattern on the planet. This shift proves that planetary rotation acts as the physical container for our oceans, holding them within their current basins through continuous motion. Above the surface, the atmosphere also retains its momentum. Without the ground moving beneath it, the air must seek a novel physical equilibrium over a static landscape. On this map, Earth's rotation deflects moving air, organizing it into sweeping cyclonic patterns that drive our weather. When rotation stops, the Coriolis effect vanishes. Global atmospheric circulation loses its structure and collapses into strictly linear flows between the equator and poles. This shift redefines the sky itself. Because the Earth would still orbit the Sun while no longer spinning on its axis, the Sun would appear to move across the sky only as fast as the planet moves along its yearly path. This orbital geometry creates a year-long day. A single location would endure 6 months of continuous, intense solar heating, followed by 6 months of uninterrupted darkness. While the remaining atmospheric and oceanic flows would transport some heat toward the dark side, the planet would still oscillate between hostile thermal extremes. Without a steady spin to distribute solar energy, the climate system enters a state of prolonged, uninhabitable intensity. Rotation also exerts a subtle influence on gravity. The outward push of centrifugal force slightly reduces the effective gravitational acceleration experienced at the equator. If the planet halts, that outward push disappears. Objects at the equator would immediately experience a slight increase in their effective weight. Over millions of years, spin has defined the planet's dimensions. This 3D wireframe illustrates our oblate spheroid shape, where centrifugal force created a permanent equatorial bulge. On a geologic timescale, a non-rotating Earth slowly seeks a new equilibrium, gradually shifting toward a uniform sphere. The planet's spin dictates its physical dimensions and its long-term geological integrity. On the surface, the biological consequences are immediate. Plants and animals have evolved to thrive within specific rotational cycles, and a sudden deviation places them under fatal stress. Circadian rhythms, the internal clocks governing sleep, feeding, and hormone regulation, would lose their environmental cues as the 24-hour day vanishes. Photosynthesis would be severely disrupted. global plant life would struggle to survive the transition from regular cycles to months of scorching light followed by months of deep freeze. Human agriculture would face a total breakdown. Our food systems rely on the predictable seasons, daily sunlight, and rainfall patterns generated by a rotating globe. Infrastructure and transport networks would fail as stable coastlines shift and predictable weather baselines disappear. In the distant future, Earth would settle into an alien environmental equilibrium with a newly distributed map of ice caps, deserts, and habitable zones. The constant rotation of our planet dictates the behavior of our oceans, the patterns of our weather, and the rhythms of our biology. It is the silent architect of the world we know.